Okay. Hello, everyone. My name is Amrut. I work with Uber as a senior staff engineer from our Hyderabad office. And since last 2 years, many teams at Uber are experimenting with latest AI technologies. And we have built a lot of agentic applications for customer support, for other things. And we have learned a lot of best practices that we have used to create the reliable agents. So today I'm going to share some of those best practices, what allowed us to build really reliable agents. So this talk is actually divided into 3 parts. In first part, I'm going to talk about what AI agents are and what agentic tools are, how agents are empowered by using tools, how these tools work under the hood, and how we can actually make sure that these tools are reliable. In second part, I'm going to talk about the learnings that we have. Basically, how do we apply best practices in tool design so that agents are more reliable? And finally, I'm going to talk about MCP, which is Model Context Protocol, how MCP works and how we can actually implement and design tools using MCP. Okay, I think most of us have heard that 2026 is the year of agents, and a lot of companies have launched agentic applications. Uber also has launched agentic applications for customer support. But there are a lot of definitions floating around what exactly agents are. So for the purpose of this talk, I'm going to define agents based on their capabilities. So agents are actually just software components, right, that are capable of handling certain tasks and complete those tasks. These agents can actually understand the task, they can reason about the task, they can plan. And if you really think about it, the traditional software is really different from agents, right? When we are designing and implementing traditional software, most of the understanding and reasoning is done by developers, engineers, and all that planning and reasoning is captured as part of the code, and machines just execute that code. Machines don't really understand anything. So in that way, AI agents are really different from our traditional software. Agents have memory, and agents use memory to reason about the tasks. And now with tools, right, agents can access latest information, and they can act on user's behalf. So unlike traditional software, agents are like human agents, what we do as developers. So humans use brains, right? We use brains to reason, to plan, and to think, understand. Large language models, right, LLMs, they act as brains for these AI agents. Now, we all have memory, we have learned a lot of skills in the past, and we use all the memory that we have, the skills that we have learned to achieve certain goals, to complete some tasks. LLMs use context as this memory, and this context can have instructions, task information, and tools information. And last but not the least, right, agents can use tools. For example, we humans, right, we use hands to do tasks, right? We use eyes to gather information. But we also use specialized tools like thermometer or hammer to get some specialized information. Now, these tools really actually change things for AI agents. And these tools turn AI agents from thinkers into doers, right? Now, this reminds me of a meme that I saw some time back. The meme said that we want AI agents to do laundry so that I can do poetry, but we are stuck with AI agents who are doing poetry, and I'm still stuck doing laundry. Well, with tools, maybe very soon, in someday, AI agents will be doing laundry, and so that we can do follow our hobbies and spend time doing something that we enjoy. And here is one example, right? What you can really achieve with tools. This is a very simple example. So let's say in 2022, when ChatGPT was first launched, if I had asked ChatGPT at that time a simple thing, right, like get today's temperature and email it to me, it will tell me how I can do it, right? But it wouldn't really do it for me. It will say that you can visit weather.com, get the temperature information, and it can tell me how I can actually compose a mail and send it myself. But today, if you really try this, AI agents can, with tools, right, really do the things end to end. It can figure out that I'm in Bangalore. It can figure out that the current temperature is whatever, and it can find out the user's email address and send, right? So these agents are really autonomous in that sense, right? And what has changed is that now agents can use tools. So there are a bunch of different types of tools that agents can use. First one is really straightforward, right? These are read kind of tools where agents can use these tools to gather information. Examples are like weather tool, where agents can use this tool to get current weather information, or web search tool, right? Where agents can go and search the web to find information. But then there are modify or write kind of tools, right? Where agents can actually use those tools to modify the state or trigger operations. For example, agents can use tools to send mail or delete user from a system. And then we all know that LLMs have a limitation, right? LLMs can hallucinate when tasks are really complex. And it's kind of known that if you give a really complex algorithmic task to LLMs, they are not going to be able to complete it. For example, like Tower of Hanoi algorithm, right? LLMs won't be able to solve it without any help. So then there will be tools like algorithmic computational tools, where LLMs can actually use those tools to do complex algorithmic tasks. Okay, so now we have talked about what agents are, how tools are going to empower agents to do stuff that was not possible earlier, and the kinds of tools. I'm going to peek under the hood, how agents and tools and LLMs work together to achieve some task. So let's say we are designing an agent, which is represented by the rectangle in the middle. When we design this agent, we are going to give some instructions, right, in terms of prompts. And we are also going to give access to some tools to this agent. We are going to explain how those tools work, what are the inputs to the tool, how the output looks from the tool. All that information is upfront available to the agent. Now, these agents can talk to LLM, which is the rectangle on the right, on the left, and on my left, right? So agent can actually communicate with LLM and get stuff done, right, for thinking and planning. So now let's say there is a user application. It could be a chat bot or some other application that sends a task to this agent. Now what agent is going to do at that point is it's going to take this task, it's going to take all the instructions that we have given to complete that task. It's going to look at all the tools that we have given, information about all those tools. It's going to bundle all that together and send it as context to the LLM, right? So LLM at that point is going to analyze all this context, and it's going to do two things. It's going to select one of the tools that it thinks that can help completing the task, and it also is going to extract information from the context to create the input parameters for the tool. Now, how does LLM really do this, right? Well, these LLMs are huge models. They have like billions or maybe trillions of parameters, right? They are trained on vast amount of data, maybe like the entire internet, right? But these LLMs are also fine-tuned to actually select tool and create input for the tool. So that fine-tuning actually allows these LLMs to do these things, right? They can select the task, select the tool, and create the parameters, input parameters for the tools. Now, when LLM actually does that, right, when it selects one of the tools, it creates the parameters, input parameters for the tools, it's just going to pass it back to the agent. And agent at that point is just going to call the tool with the parameters and get results back. When the tool results are available, agent is going to pass it back again to LLM. right? And LLM is going to analyze those results. Now, at that point, LLM may want to run another tool, right? Execute another tool. And if LLM thinks that another tool is needed, then the whole process repeats again. And this process can repeat again and again in a loop till LLM figures out that task is done. And when LLM figures out that task is done, it's going to create a task result, send it back to the agent, and agent is going to pass it back to the user application. So this is the whole cycle for every tool use that happens in the background when LLMs or agents use the tool. Now, there are a couple of interesting points here, right? So if you really think about it, LLMs here are never interacting with the tools. LLM's job here is just to select the tools and create the inputs for the tools, right? Actual interaction with the tool is happening on the agent side. Now, these tools, right, can be local or remote. And what I mean by that is this tool could be as simple as a function in the agent code, or it can be a web service hosted in the cloud. An agent can actually make a call to that web service and get the result back. Now we all know, right, LLMs can hallucinate. I think that's one of the biggest limits that we have. Now in the whole, I think the process, we are using LLM for three things: tool selection, parameter creation, and result analysis. And we can expect hallucinations at any of these points, right? LLMs can select a wrong tool, or maybe it will say that there is no tool that I can use when there is a tool existing that it should use. It can probably create wrong input parameters. For example, it can just create a new field in the input which is not really required for the tool, or it can actually select wrong values for those parameters. And finally, LLMs can hallucinate, right? They can, when task is complete, they can still feel that they need to do more calls, or they can say that, okay, tools are basically done, and bail out on the task, right? So hallucinations are possible at all these points. And when we are designing agentic applications or the tools, the biggest challenge that we are going to face is how do we design these agentic applications and the tools to reduce the hallucinations. And that brings us to the second part, where we are going to see how we can design tools so that agents can be more reliable. Well, I have discussed some of this already, that tools need to be designed, right? I think they cannot be just an afterthought. They have to be part of your agent design process. Because if tools are not designed well, then your agents are not going to be reliable. They are not going to be efficient. And we all know that LLM providers, right, they charge us based on number of tokens. So it needs to be very really important to design the tools so that the tool interactions, right, are cost-effective, token optimized. So show of hands, right? How many people here have heard about prompt engineering? Okay, looks like everyone has heard about prompt engineering. And I'm not surprised, right? I think this has been a topic of interest for last couple of years. There have been books written about it. There have been courses about it. A lot of YouTube videos, right? It's basically, prompt engineering is nothing but collection of best practices on how we interact with LLM. How do we create prompts so that LLMs understand the intent behind what we are trying to do? Okay, and how many of you have heard about tools engineering? Okay, there are only few. And that makes sense because the term doesn't exist, right? And because no one is talking about how to design tools to increase reliability, right? But I feel that tools engineering is as important as prompt engineering, and more and more people should know about this and should start thinking about this when they are designing agentic applications. Maybe we can start a hashtag, Justice for Tools Engineering today. So what is tools engineering, right? Just like prompt engineering, it's collection of best practices for designing tools that allow AI agents to be reliable, autonomous, and effective. So we at Uber, we have designed a lot of agents. So now I'm going to share some of these best practices for tool engineering that we have come across to increase the reliability and autonomous behavior. But for that, we need an agent, right? So I'm going to think about this example agent and the task that this agent is going to do, right? I'm going to design this agent to this very simple task. Again, we have seen this before. Let's call it temperature task. So when I'm designing the agent for this temperature task, the first thing that, or the first decision that I have to take, that do I really need tools? Well, when you look at the task, right, it's pretty clear that we want agents, right, to collect information, right? It could be location information, it could be temperature information, and we also want agents to take some actions, right? We are asking agent to send a mail on user's behalf. So we really need tools, right? But then how many tools and what these tools should do, right, is the next decision that we'll have to make. Well, we can actually start with just one simple tool, right? And let's call it send weather report tool. Now, this tool, it does a bunch of things, right? It queries the location, gets the temperature, finds the mail ID, and sends the mail. Now, when we are thinking about designing a tool like this, right, think about what is happening. Who's doing the thinking here, right? Here, the engineer or the developer has to figure out what the order of operation should be, right? And they are going to think about that order and hard code it in the tool. So most of the thinking here is, again, is done by the developer and the engineer, but that's not the promise of AI, right? We want AI to do the thinking and be autonomous, right? Let AI figure out what tools it needs. Let AI use the tools when it needs, right? So that can be only possible if we design the tools as building blocks for AIs, right? And then just give these building blocks to the agent and let agent and LLM figure out if they want to use the tools, when they want to use the tools, and how they want to use the tools, right? So the first best practice is probably the most important one, right? We want to make sure that the tools that we are designing for agents are not really like circuits that are really task specific, but these tools are more like the building blocks that agent can use. And this is also important, right? Because let's say tomorrow requirements change, and we all know that requirements do change, right? So let's say the temperature task changes where we want not only the temperature, but let's say forecast for next 10 days also to be made. Now, what are the options here that developer has? Developer can just scrap the old tool and create a complete new tool. Again, all the thinking is done by the developer here. Or developers can just decide to hack this tool and add one more step there. Again, all the thinking is done by the engineer or the developer, right? So this is very rigid. This is not really helping agent with autonomous behavior. Most of the thinking will be done by engineer here. So here is the good example, right? So we can actually create tools like get location, get mail ID, get temperature, and send mails, which work like building blocks for the AI agents. Now, when we give these tools to AI agent and the task, agent actually figures out when to use which tool and what should be the input parameters. So autonomously, it can actually complete the task. Now, when the requirements change, right, all we have to do is maybe create another tool, another building block, let's say get forecast, and give it to agent. And let agent figure out where in the flow it needs to call this, right? So that autonomous behavior is kind of maintained. And I can also think about, let's say, the task changes to like send location information in the mail. Now with these building blocks, AI agent can actually do that task also. So tools in a way become reusable for different tasks that we can throw at the agent. Okay. Now this should be kind of obvious, right? Intuitively, I think everyone understands that tools need to be predictable, right? But one of the reasons why this is a good practice, right, or one of the best practice, is that it's probably very easy to define the behavior clearly if tools are predictable, right? Because we are going to describe the behavior, and then based on that description, LLM is going to select the tool, right? So if you can really describe the behavior easily, then LLMs can actually use it reliably. So that's why predictable tools are preferred over tools that can do different things every time you call them. Next one. So this is something that we came across when we were designing an agent for our customer support team. So one of the requirements for the agent, or the task for the agent that we were building, was to get email ID for a user, right? Now these email IDs were stored in one of the database tables, and the same agent, we wanted that agent to do some other tasks also, which kind of are retrieval tasks from the database. So we thought that, okay, let's create a very generic tool. Let's call it QueryDB tool. And QueryDB tool, the input would be database table and an SQL query, right? Now this is generic reusable tool that can be used for any task where agent has to retrieve information from database. And when we designed this, it worked. It worked for the first use case. It worked for second use case. But then engineers started building more and more use cases for this same tool, right? Use this for getting mail address, right? Use this for getting normal address, right? Use this for getting some customer preference, right? So this basically started being used in multiple different use cases. And when more use cases were added, we found that reliability dropped. That basically LLM started hallucinating. They started using wrong tools, wrong tables. They started creating garbage SQL queries. And the reason that we found was that when you are creating a very generic tool like this, right? Think about it. What all LLM has to do to select this tool? First of all, it has to understand the task and then select that, okay, that task is somehow related to QueryDB tool. Then it has to go and select a table from a lot of tables that we have. And then it has to create an SQL query, right? Look at the context, figure out the where clauses, the select clauses, right? So it became like really complex task for LLM. Whenever you ask LLMs to do multiple steps, it's going to hallucinate. The probability of hallucination goes high. And that's why when the use case was just one, when we gave only one table to LLM, right, information about one table, it worked well. But when we started putting more and more information about more and more tables, right, hundreds of columns, it started hallucinating. So then we said that, okay, maybe generic tools are not going to be scalable. They will work for POCs, but when you want to actually launch in production, you want reliability, right? Generic tools may not work. So we created like simple tools like get mail ID with user ID, and then it started working reliably. Okay, I think this is kind of straightforward. If you give LLMs tools that can do same or similar things, it may not have, I think, good idea which tool to use, right? And it may hallucinate. Maybe both the tools or like multiple tools can do the same thing, and it doesn't really matter which tool you select. But think about it. When there are multiple paths that agent can take to complete a task, creating evals for those tasks, right, becomes really difficult. I think someone was talking about evals and how evals are also important for reliability of the agent. So if you create tools with overlap, first LLMs can actually hallucinate, But again, your evals become really tough. So avoid creating tools with overlaps. Now, this is kind of like not just one best practice, but it's like bunch of different ones. So let's say we want agents, LLMs to select the right tool. Now LLMs are going to select the right tool based on the description that we provide in the context for the tools. If that description is just one-liner, right, I think it will work for your POC, right? I think no problem there. But when you want to put it in prod, it's going to fail. Because if you really think about it, one-liner description like this, LLMs don't really know what input is going to take, right? What are going to be the outputs for that tool, and it's going to hallucinate at all 3 points. On the other hand, if you create good descriptions, right, where you are giving information about output, right? For example, here we are saying that temperature will be in Celsius, right? It gives information about inputs, right? Which parameters are required, right? What values, the types of the parameters. Now, with all this information, LLMs can select the tool and also create the input parameters more reliably. Okay, so we all know that things can fail, right? Tools are like just functions or maybe web service APIs. They can fail, right? For multiple reasons. Network may be down or whatever. Now, when they fail, if you remember the whole process, how tools work under the hood, the output of tool, right, including errors, it actually goes back to LLM. Now, interesting thing here is because LLMs can think and understand and reason, they can probably understand this error and maybe autonomously take actions to fix that error, right? But if your error description is not good, right? Like for example, let's say we pass longitude as string instead of double, tool is going to fail because it expects a double there. But if you just send an error, validation errors, right? LLM is not going to understand this. It's going to try multiple things, right? Because it doesn't really know what failed on the tool side. On the other hand, if you give a very descriptive error like this, right, that is a string instead of double, then LLM now knows exactly what happened. And then it's going to create input parameters again, right? Make sure that this time it's going to be a double and not a string, and retry, right? And then it may be successful. So good error strings, right? Descriptive errors is something that will allow agents to be more autonomous, right? And in traditional software, I think we send errors, right? Basically for logging purposes, right? So that later on when something fails, right? Engineers or developers can go and look at errors and see what happened. Or we can actually just write code to handle error codes, right? It doesn't need to be very descriptive, but this is very different for agents. Now, another thing, right? What we found out that when our input schemas were very complex, LLMs started hallucinations, right? They couldn't really come up with the right input parameters for the tools. For example, let's say a get temperature tool, right? Let's say it has a location type and a nested structure where latitude and longitude. Because it's a complex structure and we are asking LLM to do more work to actually come up with these params, the probability of hallucination actually goes high. On the other hand, if you just keep it flat, right, I think the reliability increases. And this is what we have started doing. That initially we said that, okay, maybe more nested structures so that we can have good isolation, etc. But then now we said that, okay, flattened schema is the way to go for input. Okay, now even when you follow all these best practices, right, you come up with good descriptions, you come up with good error strings, right? You follow the building block strategy, LLMs can still hallucinate, right? That's just the fact right now. Now, when they hallucinate, right, how should tools react? And that's what this best practice says, that we need to design tools to be safe, right? All tool accesses, right, should be authenticated and authorized, right? Because it's possible that input parameters could be completely wrong, right? For example, let's say LLMs hallucinate and they start sending mails on behalf of some random users to random people, right? It is going to create a lot of problem for customer support agent. So now, if you have authentication and authorization, then we can say that this agent can send mails only to these users, from these users, and everything else should be blocked, right? So that's one of the ways where we are putting guardrails to make tools safe, right? And even after that, sometimes bad things do happen, and that's why audit logs are super important for tools. I think observability of tools, right, is something that is very important, because when bad things happen, you need to be able to trace what really happened and maybe fix it, and so that agents can actually start working again. So audit logs, authorization, and authentication. Another thing that we found out, right, that when we gave access to destructive tools to agents, right? For example, we talked about delete user tool. Now, this is a destructive tool, right? It's going to wipe out users' information from database. And now, when you have given access to such destructive tools, I think someone was talking about Replit. I think we saw that in production, it started deleting tables. One thing that we found out is, I think, like, make the destructions reversible. So we can't really completely stop hallucinations, even with authorization or authentication. But when they happen for destructive tools, you should be able to reverse the effect. So one thing that we are doing, for example, something like for delete user tool, right? That we don't really delete the user completely. We just mark them for deletion, right? So that later on, when someone says that, no, this was a hallucination, something wrong has happened, we can actually retrieve just by changing the state. So we actually mark it for deletion and trigger a review process, maybe a batch review process, or that review process also could be AI driven, right? Some other AI agent can review if this was hallucination. But this is super important to make sure that tools are safe. Okay, so now we have talked about best practices, all the learnings that we have. There may be more best practices in tools engineering, but let's see how we can actually implement tools that follow these best practices. So when I'm implementing the tools, right, what are my real requirements here? Of course, functional requirements are known. We know what tools we are designing. We know what tasks those tools should do. But I want to design tools, right, where not only my agent, but probably some other agents also can use those tools. And if I'm designing an agent, I want to give access to this agent, not only tools designed by me, but tools designed by other teams, right? Maybe other companies. So interoperability, right, is one of the requirements here, right? Interoperability between AI agents and AI tools. Another requirement that I have is I want my agents to be extensible, right? They are designed for certain tasks, but it's possible that end users may want different information or like different tasks for them. For example, some user may want to give more information, their own email address or their own mailbox, their own database. I want them, the end customers, to come up with their own tools and extend the agents that I am designing. And I also want agents to discover the tools that I am designing, right? If every time I design a new tool, if I have to go and update all the agents, it's going to be really tough. So discoverability is also a requirement. Model context protocol actually solves all of these, right? MCP allows interoperability between agents and tools. So let me introduce what MCP is. So it's an open source protocol from Anthropic, right? It's not very old actually. The first specification, I think they published in November last year, so it's not even a year old, right? Anthropic also open sourced the SDKs for Python and I think for TypeScript. But then there are a lot of open source SDKs available for other languages, right? You will have open source SDK for Go, right? For Java. So all those things are available. Though this is a very recent protocol, it's been adopted by industry leaders, right? For example, Microsoft uses MCP for GitHub copilots, right? Or their copilot agents. Anthropic, of course, is using it for Claude and all their agents. OpenAI is supporting ChatGPT, supporting MCP for ChatGPT. Then there are IDEs, right? Like Cursor AI or Windsurf, right? They also support MCP. So it's kind of clear that MCP is here to stay, right? More and more stuff is being built on top of MCP. So it's, I think, important for us to understand when we are implementing tools, how we can leverage MCP. The core promise of MCP is basically build once, right? So that it can be used with multiple agents or build an agent that can use multiple tools. And MCP is actually not just about tools, right? It supports more things like prompts and resources, but for this talk, we are just going to focus on tools. So when we are implementing tools for agents, it's important to understand the whole architecture of MCP. And it's not really complex, it's really easy. So let me just spend a couple of minutes to explain that. So when you are designing an agent, right, you are actually, agent that uses MCP, you are actually designing an MCP host, right? So Windsurf or Cursor AI or ChatGPT agent, these all are like MCP hosts. And if you are designing tools, then you have to design MCP servers. And I'm going to focus mostly on remote tools here because those are the interesting things. I think local tools are possible, but most of us are probably interested, or at least in Uber, we are interested in remote tools. So when you are creating these remote tools, you will be designing MCP server. Now, when MCP host wants to connect to MCP server to use a tool, it has to create an MCP client first. So for every server that host wants to create, it's going to create a separate client. And this client is used to actually manage the entire life cycle of MCP session for those tools through that server. Now, on the other hand, the server, right, it has some tool handlers, and it's going to open, the server is actually very similar to any web server, right? It's going to open an HTTP listening socket and start listening on it. So now when MCP client wants to connect to MCP server, it's just going to send an HTTP post request to the server. But the payloads on that HTTP post request, right, are going to be MCP protocol payloads. These are just JSON RPC objects, request and response both. So servers are going to respond to the requests from clients using the same JSON RPC payloads. Now let's see what tool capabilities MCP provides, right? So using MCP SDK and the protocol, servers can define tools, the handlers, then input-output schemas with field descriptions. It can provide tool descriptions. And server also can give some hints about how tool works, right? Behavior of the tools. For example, a server can say that this tool is a destructive tool, right? And that information finally goes to LLM so that LLM can actually take good decisions. Tools can be destructive, tools can be read-only. So all those hints MCP allows you to provide. And on the client side, right, on the agent side, agents can now use MCP SDK and MCP protocol to discover the tools that server has. And of course, it can invoke tools and execute tools. So the whole tool life cycle for MCP actually happens in 2 steps. So when MCP client is created first, it's going to connect to MCP server and discover all the tools, right? The way it's going to do that is by sending like method or sending a command called tool/list on the HTTP post. And at that point, server is going to just create a list of all tools that it has, and it's going to send it back to the client. Now, under the hood, right, I just want to give like little bit a deeper understanding of how the payloads look for MCP. So for MCP tools discovery, right, you can see that the payloads actually are JSON RPC payloads. Now, each request that client sends, right, has to have a unique ID. And then method is nothing but the command that client wants to execute on the server side. And for tool/list, the discovery command, there are no parameters, right? Now, when server receives this command, it's going to actually round up all the tools and create a list. It's going to send a response like this, right? Again, a JSON RPC payload. This ID, right, must be same as that of client. And the result is nothing but like a list of tools. And it has information like name of the tool, the description, what the tool does, and a lot of information about the input schema, right? It can say that it requires a parameter called city. The type of parameter is string, and the description of that parameter is something. It can also send information like, okay, I think there is a mismatch here, this should be city. But it can also say that which parameters are mandatory and which parameters are optional. Now the second step, right? Now let's say client has received list of all tools and LLM asks agent, right, to execute one of those tools, right? At that point, client is going to call tool/call method for the server. And then server is just going to execute that tool and send a response. Again, I think the payloads, right, for that are similar. It's a JSON RPC payload with an ID. The method this time is tool/call. And at this point, the client is going to send the parameters and parameter values, right? So this is basically name of the tool, and these are the arguments for input parameters. Now, these parameters are actually constructed by LLM, given to the agent, and then agent sends it to server as part of MCP protocol. And server at that point is going to just execute that tool, the get temperature tool, get the result, package it in the content. It can give a hint saying that the tool execution was successful, or if there was a failure, it can say that it was a failure. Now, this is a toy example that I created, basically to demonstrate how MCP SDK works. But also I want to point out the best practices that we discussed, right? So it's a really small example. The idea here is that when we run this, it's going to create a web service. It's going to listen for commands, MCP commands on the network. And then it's going to expose a tool called get temperature, right? So how do we use the SDK to do this? So Python SDK, right, gives a primitive called fastMCP. All you have to do is call this, give some information like name of the tool or the IP address where you want to host it and the port number. It creates the object for this, and then you have to create a handler for the tool. Now you can see that we have actually mentioned what input it requires, the types of the input, and the output, right? Output here is the class that we have defined. Interesting thing here is this class has one field, and we can also give the information or the description what that field means, right? And this handler also is pretty simple, right? It's going to call some open web API to get the current weather parameter. It's going to pass the information. It's going to unmarshal the result and create this output object and send it. Now we have to tell SDK that this is not just any Python function, but this is a handler for a tool. And you do that by annotating it with a tool annotation. And tool annotation can take multiple parameters. I think the basic ones are name of the tool and the description, right? So once this function is annotated with this tool, then SDK knows that when someone is trying to discover tools for this service, it sends this one, and when someone is trying to execute the tool, they know where the handler is. And finally, you have to execute this server, right, so that everything can run, and that can be easily done by mcp.run, and you can give a transport. Okay, so pretty simple, right, a toy example. Now let's understand if it's really following all the best practices that we discussed. Is it following best practice number 1? Well, any opinions? Right? This looks like a building block kind of tool because it doesn't really, nowhere in the code we are actually thinking about what task agent is going to do, right? We are just creating a simple tool as a building block. So I feel that, yes, best practice 1 is being followed. What about best practice 2? I think yes, because every time you call this tool, right, it's going to do predictable work, right? It's going to actually call the same endpoint. It's going to do same unmarshalling, and it's going to follow the same algorithm to create the output. So best practice 2 looks like we are following it. Is this a specific tool and not a generic tool? I would say yes, right? Very specific to the task that we are trying to do, right? We have get temperature. It's not very generic. It will be called exactly when LLM or agent needs temperature. Well, there is only one tool, right? So definitely there are no overlaps. So best practice 4 is being followed. Now best practice 5, right? Is this tool LLM friendly, right? And I think that it's not. Can someone tell me what is missing here? Okay, error handling is not there. What else? What is that? Markdown for? No, I think LLM doesn't need to understand what this code does actually. See, LLM needs to understand what the tool does, right? The code, right, like we discussed earlier, LLM doesn't really interact with the tool, right? LLM just selects the tool based on this description and creates input parameters. So anything else? Yes? Input parameters should be mentioned first and then the output? Correct. So information about input parameters is not in the description, right? Though SDK creates, it gives information about the types, the description, right, we need to give, right? So definitely we are not giving information about input parameters. What else? Sorry? Exception handling? Right, I think error handling, right? I think, for example, let's say this API call fails, right? It's going to dump a stack trace, and now that stack trace is going to go to LLM, and LLM will be super confused about exactly what happened. So exception handling or error handling, creating descriptive errors, right, is something that is really important. Okay, so looks like because this is a toy example, right? This will definitely, this will work as a POC, but definitely will fail when you try to productize it. Next one, is this code safe, like, or the tool safe here? It's safe? It's not safe? Sorry? Okay, so authorization is missing. Though this is a very simple tool, right? It's just a read-only tool. It's always a good idea to put authorization. So definitely that is missing. What else is missing? Right, when things go wrong, right, there is no observability here. We are not creating any audit logs or audit records so that later on we can really think about what went wrong and how we can actually change this. Is there anything else that is missing? Well, something that I have not discussed, but something that is very important, right? It should have been one of the best practices. This tool, right, is not really rate limited. And this we found really the hard way, right? No one thinks about rate limiting the tools when we are doing POCs, and POCs work great. But when we launched some of the agents in production, because of hallucination, sometimes agents go into loop, right? For example, think about a scenario when agent can go into loop and start using send mail again and again, right? You will spam so many people. So we started thinking about rate limiting the tools. And that's another thing that you have to do to make the tool safe. So rate limiting definitely is missing here, just a toy example. Sorry? Moderation. What do you mean by that? Right, well, so here, right, the input is just going to be in this format. We are not taking prompts as inputs, right? So I think prompt injection may not be the issue, but input validation definitely is missing here, right? See, for example, we all know lat and long, right? They have certain ranges. So we must check for those ranges. And if the input is out of that range, let's say LLM has hallucinated, and given input in wrong format or out of range, we should actually do validations and return errors. Okay, so these are the input improvements that we can do to make sure that our agent, our tool, right, is actually following all the best practices. We can add descriptions for input parameters. We can add validations, right, descriptive errors. We can also give annotation saying that this is a read-only tool, right? I think that also is missing, and sometimes is very important for LLMs to understand the kind of tools that you are designing. And again, authentication, authorization, audit logs, and rate limits, right? Those are missing. Okay, so we still have some time left. So if there are any questions, I can take questions. Yeah. Do we have a mic for the audience?
All right, just a quick one. Over the last few years, enterprises spent a lot of time in API-fying stuff, right? So now we are looking at creating tools. Do we have a shortcut to convert all the existing APIs to tools?
So we actually, we did that at Uber, right? Uber is mostly like service-oriented architecture. We have thousands of services, right? And all these services, they expose APIs, right? Like open API formats and all that. So our first idea was, can we just convert these API specifications to tools, right? So we started doing that. It was not very hard to do, right? I think we had, like most of our API specifications are in some ideal format, right? Interface description language format. So it was kind of easy to convert APIs into tools, right? Now, when we started doing that, again, POCs worked. I think that's the beauty of designing agentic API, right? POCs always work, POCs are always mind-blowing, right? But when we started evaluating them in production, right, with more complex use cases, we found that APIs, right, were really designed for machines to understand, right? Machines were parsing those APIs and taking actions on them, right? They are not really LLM friendly. Sometimes APIs were overloaded. They had a lot of input parameters, really nested structures. The outputs also were overloaded, right? Because APIs were not used only for one, I think, purpose. Different services were calling the same APIs and getting different parts of the output. So though it could be a strategy going forward, but for that you need to make sure that you have designed the APIs with LLM in mind. right? Otherwise, you will actually have a lot of reliability issues. It won't be token optimized because sometimes API outputs, right, are like really huge, right? Because we didn't really care when we were designing those APIs. Those were really easy to parse for service-oriented architecture. So start with that. I think that's what we did, right? We bootstrapped our agents with that approach. But when these agents started hitting some wall in terms of reliability or cost, we started moving towards more LLM-specific tools to increase the reliability.
So, Amrit,
Yeah.
thanks a lot for this session. This was really helpful. I have a very basic question. So, client need to connect to the tools.
Mm-hmm.
How it will find where are the tools registered? Do we have some kind of tool registry where my client can go and look up all the tools?
Very good question, right? So right now, MCP supports tool discovery, but you still have to discover the server, right? Once you have access to server, then you can actually discover the tools that the server supports. But how do you discover the server itself, right? So Anthropic actually is working on an open source protocol for server registry, right? But before, like they released it, right? We at Uber, right? We actually face the same problem. So we actually started working on creating our internal registry. And that registry is not only for discovery, right? That registry is also used for authentication and authorization, right? This registry...
Kind of gateway.
Exactly, right? So this registry, when an agent connects to this registry to discover the servers, at that point, we can actually enforce some authorization policies and say that, okay, no, this agent is not allowed to use this server and this tool. So maybe wait for, I think, few more months. Anthropic will solve it for us. But I think it's not very hard problem to solve also. It's just a database and some policies on top of it. Thanks for the question.
I had another question. With connection to the same earlier question. So, as you said, you have different existing APIs which is already available in the form of open API specification. You are trying to leverage that at some extent, although not always possible. And it is also possible that some of the APIs may be designed in different other programming languages. So not always in Python. There might be different other technology stack behind this. So, but as an agent, when they're just sending a request to the server, in this case, the MCP server, and then ideally the MCP server is what is actually executing that API in question, and then returning the result. But since there might be multiple different technology stacks involved, how that actually works here?
So I think, right, like when you design an API or a service, right, the communication between client and server, right, is through a specification, right? It doesn't really matter what language the server is designed in and what language the client is designed in, because the communication, right, like for example, when we are talking about it, right, we are talking in English, right? It doesn't matter where you are from or where I am from, because we know the same language, right? Same communication language, not the implementation language. So that's how that problem is solved. That you don't really need, or like client doesn't really need to depend on the programming language for the server.
Okay. And in case some of those very localized...
Maybe,
okay,
I think we can, yeah.
Yeah, so
By the way, I'm going to be available. We can connect outside.
one question I had to ask actually. So we were discussing about, using LLM to select the tools. Now, you also mentioned that there is cost factor. How do we exactly manage the cost factor when we are selecting tools with LLM? Because we know these are costly calls and there might be multiple calls to select the tools.
Correct. So I think one of the things that we have to do is basically make sure that the descriptions that we have, right, are effective but token optimized, right? The input for the tools are effective, easy, but also token optimized, right? And that's why I think one of the best practice was basically to create a flat structure for input. Even outputs, if they are flat, right, then you are not asking LLMs to create more tokens, right? So that way, I think you can actually manage the cost. But again, it's going to be a trade-off, right? I think if you put less information in the context, the chances of hallucinations are high. But if you put more information, then cost is going to be high. So I think you have to monitor both, right? You have to monitor the hallucinations, and you also have to monitor the cost and strike the right balance.
Thanks.
Thank you. I think
Given
we are
the
out
paucity
of
time,
time.
we'll take the questions offline.
Yeah,
Is
maybe
that okay?
we can meet outside and we can
Yeah.
Discuss.
Thanks,
Thank you.
Amrut, for
Thanks,
this
everyone.
insight.